Dear students, in this video we will deal with monosaccharides. In the previous video I have dealt with the classification of the carbohydrates. Now I have already told you that how the carbohydrates have been classified as monosaccharide, oligosaccharides and polysaccharides. As you all know that monosaccharides are the hydrocarbons, simplest hydrocarbons or you can say simplest carbohydrates which do not hydrolyze further. And there are about 20 monosaccharides which occur naturally. Now let's see how these monosaccharides are classified. These are classified on the basis of two categories. Number first is on the basis of the functional group present in it. So depending on the nature of functional group, there are two types of monosaccharides, aldoses and ketoses. If a aldehydic group is present, then it is called aldoses, and if the carbohydrate or monosaccharide contain a ketonic group, then it is called as ketoses. Now here you can see I have drawn a simplest structure of a aldoses and ketoses. This is the simple aldoses and ketoses structure. And in aldoses, you can see the value of N may vary from 1, 2, 3, 4 or 5. And in ketoses, the value of N may be 0, 1, 2, 3 or 4. Now the second classification is based on the number of carbon atoms. Monosaccharides are classified as trioses, tetroses, pentoses, hexoses and heptoses if there are 3, 4, 5, 6 or 7 carbon atoms. Now if there is an aldose with 6 carbon atom, you will write the name as aldohexose. If there is a ketose with 6 carbon atoms, you will write ketohexose. So depending on the presence of aldehydic and ketonic group and the number of carbon atom present, we can easily write the name of the monosaccharides. Now dear students, let's come to open chain structure of monosaccharides. The open chain structures of monosaccharides of trioses has been first dealt with. You can see the trioses, this is the simplest carbohydrate with general formula C6H6 and O3. And here you have been shown the simplest aldotriose, that is glyceraldehyde, and a simplest ketotriose called as dihydroxyacetone. The structure has been shown to you by taking C carbon atom as 3 in number. Now as you can see in this glyceraldehyde, there is an asterisk has been put here. It shows an asymmetric carbon atom is present in aldotriose because it is connected to 4 different groups, CHO, CH2OH, H and OH. If you will open chain structure, you will see this carbon atom is an asymmetric carbon atom. Now because it contains asymmetric carbon atom, this compound must be an optically active compound, and it will exist in 2 optically active forms that has been shown here as D form and L form. D-glyceraldehyde and L-glyceraldehyde that I have shown you here. Okay. Now this D and L family are again monosaccharides are further classified in this D family and L family. Now how we decide the configuration of the monosaccharides as D configuration or L configuration? If the OH group that is adjacent, the OH group on the carbon atom adjacent to CH2OH group, if it is on the right side, then it is termed as D configuration. And if the monosaccharide, in the monosaccharide, the OH group lies on the left hand side on the carbon atom adjacent to CH2OH group, then it is assigned as L configuration. So this is D-glyceraldehyde and this is L-glyceraldehyde. Now but this D and L forms, they do not refer to the dextrorotatory and levorotatory. In fact, they just refer to the absolute configuration around asymmetric carbon atom. Yes, आपको ये नहीं बता रहा है D और L कि ये dextrorotatory compound है कि levorotatory compound. ये सिर्फ आपको ये बता रहा है कि asymmetric carbon atom के around किस तरीके से अरेंजमेंट है ग्रुप्स का. ये सिर्फ आपको वो कॉन्फ़िगरेशन बता रहा है कि OH ग्रुप राइट में है कि लेफ्ट में. ये आपको लीवोरोटेटरी कंपाउंड के बारे में नहीं बता रहा है. तो ये जो D-glyceraldehyde है ये भी डेक्स्ट्रोरोटेटरी भी हो सकता है, लीवोरोटेटरी भी हो सकता है, और ये L-glyceraldehyde ये भी डेक्स्ट्रोरोटेटरी भी हो सकता है और लीवोरोटेटरी भी हो सकता है. इफ द कंपाउंड इज डेक्स्ट्रोरोटेटरी देन वी विल पुट प्लस साइन, एंड इफ द कंपाउंड इज लीवोरोटेटरी वी विल पुट the minus sign in along with the D and L form, will put plus and minus sign in the compound. Now next, the classification is of hexose. You can see hexoses have general formula C6H12O6, and I have shown you 3 common hexoses here, the structure of D-glucose, D-galactose and D-fructose. Along with the carbon atoms are shown here with their configurations as well as whether they are levorotatory or dextrorotatory. Now we come to the cyclic structure of monosaccharides. Now in cyclic structures of monosaccharides, you can see here an aldehyde when reacts with alcohol, it will give you a hemiacetal and acetal, and ketone react with alcohols to give you hemiketal and ketals. Now in both these reactions, the carbonyl group of aldehyde and carbonyl group of ketone, they react with the hydroxyl group of the alcohols to form hemiacetal and hemiketal. Now since monosaccharides, it shows the presence of both hemiacetal and hemiketal, that means it must have the structure of hemiacetal and hemiketal in them. And this is not surprising. Why? Because it has both the aldehydic and carbonyl ketonic groups in it. मोनोसेक्राइड्स में दोनों ग्रुप्स होते हैं और इसके अलावा बहुत सारे हाइड्रोक्सिल ग्रुप भी मोनोसेक्राइड्स में होते हैं, तो इनके इंट्रैक्शन से हेमी एसिटल और हेमी कीटल आसानी से बन सकता है. द फॉर्मेशन ऑफ एन इंट्रामोलिक्यूलर हेमी एसिटल और हेमी कीटल इन अ मोनोसेक्राइड, इट रिजल्ट्स इन द फॉर्मेशन ऑफ अ 5 मेंबर्ड और अ 6 मेंबर्ड रिंग स्ट्रक्चर. ये इंट्रामोलिकुलर हेमी एसिटल और हेमी कीटल जो मोनोसेक्राइड में बन रहा है, उसके एज अ रिजल्टेंट ऑफ दैट a 5-membered and a 6-membered ring structure is formed. Now this 5-membered ring structure contains 4 carbon atoms and an oxygen atom, which is called furanous form due to its resemblance with structure furan. And on the other hand, the 6-membered ring structure contains 1, 2, 3, 4, 5 carbon atoms and an oxygen atom and is termed as pyranose structure or pyranose form due to its resemblance with pyran.